everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm back to my tutorial lesson in financial mathematics and exam FM preparation. And the lesson today I would like to talk about is dollar weighted and times weighted rates of return. So first let's get started off with dollar weighted rate of return. Here's the concept. Let's capital A be the amount of the fund at the beginning of a year, B be the amount of the fund at the end of the year, and CT be the deposits or withdrawal at time T. So if CT is a deposit, CT is positive, and otherwise if CT is a withdrawal, then CT is negative. Here assuming that simple interest I is applied. So in this situation, we are going to use simple interest rate, not nominal interest rate. So the amount A at time 0 will be accumulated to A times 1 plus I at time 1. Because using the simple interest rate, the accumulation function is 1 plus IT. So from time 0 times time 1, T is 1. So we have A times 1 plus I. And here is CT is accumulated to CT times 1 plus 1 minus T times I using simple interest rate. And then add them together, we have the balance at time 1, which is B. So here we are going to solve this equation for I, and we got I as B minus A minus summation of CT over A plus summation of CT times 1 minus T. And I here is the dollar weighted rate of return using simple interest rate. To understand this, we simply think about ending balance is basically the beginning balance plus deposit or subtract withdrawals plus interest. So B represents for ending balance, A represents beginning balance, C stands for deposit or withdrawal, and I stands for interest. So I here is the dollar weighted rate of return, and I here is equal the interest here is equal to B minus A minus C. So we have I is computed as capital I over A plus summation of CT times 1 minus T. But usually to find dollar weighted rate of return, I recommend you to use these formulas. Next, the time weighted rate of return. Here's a situation. This is a table of cash flows analysis. So, for example, here at time January 2nd, we deposit $1,000. So after the deposit, we have the ending balance is $1,000. On April 1st, the beginning balance is $1,100. Then we deposit $400. So we got $1,500 at the end. The ending balance is $1,500. Then on September 1st, the beginning balance is $1,200. Then we withdraw $300 because here is negative $300. So the ending balance is $900. And on January 1st next year, we got $1,300 as the beginning balance, and then we finish the time circle. So for time weighted rate of return, we are going to circle the beginning balance and the ending balance, and then we are going to take the beginning balance divided by the ending balance and then time them together. So here 1 plus I, where I is the time weighted rate of return, is computed as the first beginning balance is 1100 divided by the first ending balance is 1000. The second beginning balance is 200. The second ending balance is 1500. The last beginning balance is 1300. And the last ending balance is 900. So we have 1 plus I is equal to 1100 times 200 times 1300 over 1000 times 1500 times 900. And we got I is 27.11%. So the time weighted rate of return in this situation is 27.11%. Inflation. Inflation is the rate at which prices increase. When the inflation rate is positive, the percentage change in a fund over time is greater than the change in its purchasing power. So the change in the fund purchasing powers is the real interest rate. The effective interest rate I is often called the nominal interest rate. And here's the formula to compute the real interest rate. Here I prime is the real interest rate, I is the nominal interest rate per units of time, and R is the inflation rate per unit of time. So 1 plus I prime is equal to 1 plus I over 1 plus R, equivalent to 1 plus I is equal to 1 plus I prime times 1 plus R. And the present value in the cash flows analysis when inflation does contribute is summation of cash flows at time t over 1 plus I prime to the t times 1 plus R to the t, because 1 plus I prime times 1 plus R is 1 plus I. CFT is a cash flow at time t. So that's everything of today. Now we are going to practice some problem. Problem number 1. At the beginning of a year, an investment fund was established with an initial deposit of $1,000. 3 months later, a deposit of $200 was made. Withdrawals of $300 and $600 were made at the end of 6 months and 8 months, respectively. The balance in the fund at the end of the year was $1,400. Calculate the dollar-weighted yield rate earned by the fund during the year. So this question asks for dollar-weighted yield rate. So what we have to do is follow the formulas. I is equal to B minus A minus summation of CT over A plus summation CT times 1 plus T. Here we have the B is the ending balance. So B here is 1400. A is the beginning balance, so A is 1000. CT is the deposit or withdrawal, so we have 200 positive, 300 negative, 600 negative, because 600 and 300 are withdrawals. So we have 1400 is B, 1000 is A. We deposit 200, so we subtract 200. We withdraw 300, so we plus 300. We withdraw 600, so we plus 600 here, because minus with minus is plus. And at the denominator, A is 1000. Then the first CT is 200 and is deposit at time 14, because 200 is deposit 3 months later. So it's a time 3 over 12, which is 14. So 1 minus 14 is 34. 300 is the withdrawal, so we subtract 300. And 300 is withdrawn at times 1/2, because it's 6 months later. So 1 minus 1/2 is 1/2. 600 is withdrawn at time 8 over 12. So 600 times 1 minus 8 over 12, which is 1/3. And we got I is 6.45%. So that's how we compute the dollar-weighted rate of return earned by the fund during the year. Problem number 2. Chu had an account with a balance of $100 on January 1st and $115 on December 31st. At the end of every month during the year, she deposited $20. She made withdrawals of 15 on February 28th, 10 on June 30th, and 120 on September 15 and 95 on October 31st. Calculate the dollar-weighted rate of return for the year. So here, similar to the first problem, we follow these formulas. So B is the beginning. B is the ending balance, which is 115 because at the end of the year, December 31st. So B is 115. A is the beginning balance, which is 100 at time January 1st. So 100 is right here. Then every month we deposit $20. So 12 months we have 20 times 12. And this is minus because minus CT. Then 15 is the first withdrawal, so it's negative 15 with minus here is positive 15. The second withdrawal is 10. So minus 10 is plus 10. 120, here is another withdrawal. So minus 120 is plus. Then plus 95 is the last withdrawal. At the denominator, first we have A is 100. Then 20 at the end of each month. So it's like 20 times 1 minus 112 plus 20 times 1 minus 212 plus dot to 20 times 1 minus 12 over 12 because the last 20 is deposited times 12 over 12. That means at the end of the year. So it's rewritten in the form 20 times summation k from 1 to 12, 1 minus k over 12. So next we finish with the deposits. So now we look at the withdrawals. 15 is withdrawn at time February 28 at the end of this February. So 15 times 1 minus t. T is 2 over 12 because deposit at time t equal to 2. 10 is withdrawn at times 6 over 12 because at the end of June. So it's 6 over 12 is t. 120 is withdrawn at times 8.5 over 12 because it's September 15. So it's like at the middle of September. And 95 is withdrawn at times 10 over 12 because this is the end of October. So using this equation, we have I is 10.59%. So that's how we calculate the dollar-weighted rate of returns. Remember, for the dollar-weighted rate of return, we assume the whole circle is 1 for time, like just during time 1, 0 to 1. And all the deposits and withdrawals are made at time t with t less than 1 and greater than 0. Problem number 3. On January 1st, a fund is worth $80,000. On May 15, the fund is worth $100,000. Then a withdrawal of $10,000 is made. On August 23rd, the value has been fallen to $80,000, and the $15,000 is deposited. On December 31st, the fund is worth $90,000. Calculate the time-weighted rate of return of a year. So this is the cash flow analysis table. On January 1st, the fund was $80,000. So this is the before deposit and withdrawals. Then there was no deposit and withdrawals made. So the balance after deposit and withdrawal is 80,000. On May 15, the fund is worth $100,000. So this is the beginning balance. No deposit, but there is a withdrawal of $10,000. So $10,000 is a withdrawal. So the ending balance of May 15 is $90,000. Then August 23rd, $80,000 is the beginning balance. Then we deposit $15,000, so we got $95,000 is the ending balance. And on 31st of December, the balance is 90,000. So here we have 3 ending balance and 3 beginning balance. So the time weighted dollar is computed as 1 plus I is equal to 100,000 over 80,000 times 80,000 over 90,000 times 90,000 over 95,000. This is equal to 1.053. So I is 5.03%. So that's how you calculate the time weighted rate of return. Remember, whenever you got a question about time weighted rate of return, I recommend you to make the table of cash flows analysis and carefully compute its numbers, and then just follow the rules using the beginning balance divided by the ending balance. So now we go to problem number 4. On January 1st, a fund was opened with an initial deposit of $10,000. On July 1st, the balance was $10,800, and then an additional $4,200 was deposited. The annual effective yield rate for this fund was 6.5% over the calendar year. Calculate the time weighted rate of return for the year. So the question asks for time weighted rate of return, so we need to complete the table of cash flow analysis. Here's the table. 10,000 is the beginning balance on January 1st, and there was no withdrawal and no deposit at time January 1st, so the ending balance is $10,000. On July 1st, the balance is 10,800, and then an additional 4,200 was deposited. So the ending balance was 15,000. And they didn't give you information about the ending balance on December 31st, but for time weighted rate return, the circle should be the whole year. So the period should be the whole year. So it's mandatory to have the balance on the ending balance on 31st of December. So this money is computed using the last piece of information. The annual effective yield rate for this fund was 6.5%. So look back to the question. On January 1st, the beginning fund was 10,000. Then we deposit 4,200 at time July 1st. So we are going to compute the fund at the end of December using these two numbers. So 10,000 is deposited at time 0. 2 times 1 is accumulated to 10,000 times 1.065. 4,200 is deposited at time July 1st, so that's a half year. So we have 4,200 times 1.065 to the 0.5 because 4,200 is deposited at time 1/2. So to move to time 1, we raise to 1/2 because 1 minus 1/2 is 1/2. So we got the balance, the ending balance of December 31st is 14,984.35. So now we have finished the cash flow table. We are going to use this cash flow table to find time weighted rate of return. So 1 plus I is equal to 10,800 over 10,000. 14,984.35 over 15,000. And the answer is 1.078874 for 1 plus I. And from here we got I is 7.9%. So that's problem number 4. Problem number 5. On January 1st, the value of the fund is 16. On July 1st, prior to any deposits being made, the value of the fund is 20 and a deposit of D is made. On December 31st, the value of the fund is D. For the year, the time weighted rate of return on the fund is 0%. and the dollar-weighted rate of return is R. Calculate R. So in this question, it involves both time-weighted rate of return and the dollar-weighted rate of return. And here the question gives you the time-weighted rate of return is 0%, and one of the deposits D is unknown. So first we make the table of cash flow analysis. On January 1st, the before balance is 16. No deposit and withdrawal was made, so the after balance is 16. On July 1st, the beginning balance was 20, and then a deposit of D is made, so the ending balance is 20 plus D. On December 31st, the beginning balance is D, so the time-weighted rate of return is computed as 1 plus 0% is equal to 20D over 16 times 20 plus D, because 0 is the time-weighted rate of return. Here we are going to solve for D, so we got D is 80. And now we are going to use D to find the dollar-weighted rate of return. So the dollar-weighted rate of return is D minus 16 minus D for the numerator, because D is the ending balance, and 16 is the beginning balance, minus D is a deposit. At the denominator, 16 is a time 0, so a time 1 minus 1 is 1 minus 0 is 1, so we have 16. D is deposited at time July 1st, so it's half year, so we have 1 minus 1 half, that's 1 minus T times D. So this quantity is equal to negative 16 over 16 plus D over 2, and solve D is 80, so we substitute D as 80. We got R is negative 16 over 16 plus 40, so the answer is negative 28% for the dollar-weighted rate of return. By the way, one thing I want you to notice here, the dollar-weighted rate of return might be negative in some cases, but the time-weighted rate of return is always positive, always positive. So that is everything for today. Thank you so much for watching, and see you next time. Bye.